Welcome back. What is the value of k after the following code is executed? N1, N2, Nm are positive integers. Start with k equals 0. For I1 going from 1 to N1, so this is nested for loops. Within I1, for each I1, you have a range for I2. For each range of I2, you have a range for I3, so on, all the way until I am N1, N2. You're incrementing k in the innermost nesting. Let's look at an example and proceed. Suppose you have two n's, n1 and n2. n1 is 3, n2 is 4. Let's see how this looks like. Start with k equals 0 for I1 going from 1 to n1. Within that for loop, you have I2 going from 1 through n2. And in the innermost loop, you are incrementing k. So, first set I1 equals 1. When I1 is 1, I2 can be 1, I2 can be 2, I2 can be 3, I2 can be 4. For each I2, k gets up incremented. Start with 0, so k is now 1, 2, 3, 4. That's when I1 is 1. When I1 is 2, now k is already at 4. For each I2, k gets incremented. When I1 is 3, k is now 8, k gets incremented. In all, I land in 12. So where did I get this 12 from? Notice that's 3 times 4. In general, for our code, it's N1, N2, N3 all the way until Nm. So that's the final value of k. How about counting subsets of a finite set? Use the product rule to find the number of different subsets of a finite set S. Hint, use bit strings. Well, PS denotes the power set of S. What does that mean? Power set is the set of subsets of S. Suppose S has no elements, then it has only one subset itself. When cardinality of S is 0, then cardinality of power set of S is 1. Now, in general, suppose cardinality of S is n greater than 0. So let's say S has elements 1 through n for your namesake. Now, every subset A of S can be viewed as a bit string. Well, of length n. You see, if 3 is in A, then place 1 in the third location. If 3 is not in A, then place 0 in the third location. So 3 is just an example. If I is in A, then place 1 in the ith location. If I is not in A, then place 0 in the ith location. So every subset gives you a unique bit string of length n. In other words, number of subsets of S is the number of bit strings of length n. We have seen this already. That is 2 to the power n. Okay. Now here is product rule. It can also be stated using Cartesian product as cardinality of A1 cross A2 all the way until AM is cardinality of A1 times cardinality of A2 all the way cardinality of AM, where A's are subsets of a particular set. Sum rule. If a task can be done in either in one of n1 ways or in one of n2 ways, where none of the n1 ways is the same as any of the n2 ways, then there are n1 plus n2 ways to do the task. Okay. Suppose you have a university committee and that committee needs a representative from a mathematics department. There are 21 faculty members and 98 students in the department. Assume that no faculty member is also a student. How many different choices does of a representative does the department have? Well, only one representative is needed. There are 21 faculty members, 98 students. And nobody is both a faculty member and a student. So there are 109 options to choose from. That's all. What did we do? We just added 21 and 98. Now we can extend the sum rule to more than two tasks. Suppose that a task can be done in one of n1 ways, in one of n2 ways, or so on, in one of nm ways, where none of the set of ni ways of doing the task is the same as any of the set of nj ways. For all pairs I and j, where I is different from j, then the number of ways to do the task is n1 plus n2 all the way until nm. For example, a student can choose a computer project from one of 5 lists. There are 5 lists. The list contains 12, 21, 23, 14 and 15 projects respectively. No one project appears in more than one list. In other words, you have all these different projects. How many projects are there to choose from? Well, number of projects to choose from, 12 from the first list plus 21 from the second, 23 plus from the third, 14 from the fourth and 15 from the fifth. Just add them all up. Assuming I have added correctly, it's 85 number of projects to choose from. Here is another code. What is the value of k after the following code is executed? Okay. Start k equals 0. When I1 goes from 1 to n1, increment k. Okay, you increment it until n1. So k is here n1. For it going from 1 to n2, increment k again. So you see, this is no longer nested loop. These are separate loops. So k got incremented to n1 here. Then n1 gets incremented to n1 plus n2 all the way to n1 plus n2 plus all the way until nm. For example, when n1 is 3, n2 is 4, start with k equals 0. The first loop is only about I1. So I1 takes turn going from 1 to 3. Alright. So k gets updated until 3. Once I1 is done, now I2 goes from 1 to 4. So k gets updated after 3 until 7. So what did we do? You added n1 and n2. In general, you would add n1, n2 all the way until nm. Alright. So the general form of the sum rule is as follows. If a1, a2 all the way until am are pairwise disjoint finite sets, then the number of elements in the union of these sets is the sum of the numbers of elements in the sets. So cardinality of a1 union, a2 union all the way until union am is cardinality of a1 plus cardinality of a2 plus all the way until cardinality of am. This is the case when ai and aj have no intersection, that is, they are pairwise disjoint. Alright. Now we'll continue with more basic counting problems in our next video.